We've talked a lot about differentiating polynomials. And of course, polynomials all have cardinal numbers as their power, but there's lots of other functions. So let's have a look at these other ones. Let's start with the very basic one, the hyperbola, 1 over x. So function x is 1 over x, function x plus h, 1 over x plus h. Put it into our first principles formula. We get this lovely expression. Let's push the x plus h and the x down to the denominator, but that means the top becomes x minus h, which tidies up. The h's will cancel, and we've now got something we can substitute into. If we make h equal to 0, we end up with minus 1 on x squared. So differentiate 1 on x, we get minus 1 on x squared. Now why is that significant? Had I used the rule that we already know, then I would have said, well, 1 on x, that's the same as x to the power of negative 1. And our rule said we could bring that power down and then lower the power by 1. So if I bring the negative 1 down and lower the power by 1, I get minus x to the minus 2, which of course is minus 1 on x squared. So it appears that we don't have to have a positive whole number like a polynomial. It will work with negative indices as well. Oh, that's good. What about fractional? So let's try square root of x. Function x is the square root of x. So function x plus h, square root of x plus h. How on earth are we going to substitute into this thing? We've got 0 on the bottom of the fraction. I'm going to do something a little bit different to what we normally would do. Normally we'd say, let's rationalise the denominator. Well, I'm going to rationalise the numerator. Okay? So let's rationalise the numerator. So the top of the fraction now becomes difference of 2 squares. And we end up with x plus h minus x. The x minus x will go away. I've now got an h which will cancel with the h on the bottom of the fraction, and we eliminate our 0 over 0 problem. We can substitute into this one, and we end up with 1 on 2 root x. Well, had we used our rule that we've worked out before, I would have changed it to x to the power of a half. And then I said, oh, let's bring down that power and subtract 1 from the power. So it becomes minus a half. Let's take it out of index form. 1 on 2 root x. So our simple little rule of bringing down that power and then subtracting 1 from the power will work for any index, not just polynomials. We can use it for any index. First example. Why is 3 come? 3x plus 1 on x squared, then we get something like this. First thing I'm going to do is put that in index form so I can deal with it. So I've got x to the power of negative 2. Some people make the mistake of leaving it there because it feels like we've done something, so excellent, question must be over. But of course we haven't actually differentiated yet. So let's do that. We'll get 3 minus 2x to the minus 3, which yes is an answer. It's a mere mortal answer, but it's always good to answer the question in the format that you were given. And we were not given it in index form. So we'll change the 2x to the negative 3 to an x cubed, a much nicer answer. I think it's also better if you end up substituting in too, because it becomes a lot clearer what you're going to do. X squared root x. Okay, let's put it into index form. Well, that's 2.5, so 5 on 2 is our power. Bring down the power, lower the power. We have the mere mortal answer, super mathematicians. 5 on 2, x root x would be our derivative. 2 over 5x plus 4 all squared. Now, this I would rewrite as 5x plus 4 to the negative 2. And guess what we're about to do? Anarchy. All right, bring down the power. 2 times negative 2 is negative 4. Lower the power becomes negative 3. We're going to, there it goes. The derivative comes out and we've got 5. We get minus 20, 5x plus 4 to the minus 3. Mere mortal answer. Super mathematicians. Minus 20 on 5x plus 4 to the power of 3. Fourth example, we've got the square root of x squared minus 3. Put it in index form. So that's the power of a half. Anarchy. Bring down the power. Lower the power, minus a half, and then the fun bit where we, there it is, expel it. There, derivative is 2x. Half times 2x is x. Mere mortals. Super mathematicians. X on the square root of x squared minus 3 is our derivative. Okay, That will do us for our theory today.